Hello, everybody. This is a test simulation of two networks, one network connected by a switch and one network connected by a hub, so that we can see the different behaviors of each device, the switch and the hub, and how they differ from each other. So we have a message ready to go on the network, the switch connected network. It'll go from PC0 to PC1, and we can start stepping through it. The message goes to the switch. And at this moment, the switch knows where PC1 is. It knows its MAC address, its physical layer address. PC1 can respond and just send a message back to PC0. Nothing groundbreaking, except for the fact that this is actually a very efficient use of the network. Only PC0 and PC1 and the switch, of course, are involved in this path, this message path. Now, let's go into the next message that will go from PC4 to PC7. And this time we're going to travel through the hub. The hub is basically a repeater, so anything connected to it should receive the message. As we see the message travel through, the hub doesn't keep track of any addresses at all, so it sends it to everyone. Two of the computers will say, this message is not for me, but PC7 will recognize its address and be like, yep, this is for me, and it responds. The hub, never keeping track of addresses, repeats the message to everybody else. And you will notice that while this works for a network, it is not a terribly efficient use of the network, because now imagine all of the computers are sending messages to each other. We now have the event of collisions, which causes interference, which means that messages have to be resent. Usually a network connected through a hub or a repeater tends to really be 30% efficient because of this. While a switch suddenly jumps that up once the switch figures out where all the addresses are to like 95% efficient. So this should be this should make it clear how the different devices, switch and hub, behave and differ from each other, the switch being a smarter version of a hub.